All right, last page of R6 and R7. We did this problem in class, but I feel like it got away from me. So thought I would just toss it in as a little podcast bonus, podcast extra, I don't know, bonus episode. We have our distance, d in feet, required to stop a car that was traveling at a speed v in miles per hour before the brakes were applied. Depends on the amount of friction between the tires on the road and the driver's reaction time. After an incident, a legal team hired an engineering firm to collect data for the stretch of road where the accident occurred. Based on the data, the stopping distance is given by the equation d is equal to 0.05 v squared plus 2.2 v. Part A, determine the distance required to stop a car going 50 miles an hour, and then B, up to what speed to the nearest mile per hour could a motorist be traveling and still have adequate stopping distance to avoid hitting a deer 330 feet away. So I mentioned this in the last one. I'm going to kind of, again, just get you comfortable with the notation. Our equation is d is equal to, well, that is once again d in terms of v, right? On the right hand side, I have all terms of v. So I have 0.05 v squared plus 2.2 v. This setup's going to help a lot. So part A is what's the distance required to stop a car going 50 feet? Well, here's the beauty of function notation. You're telling me the car is going 50 miles an hour. That's the velocity. You're asking me what's the distance when that happens. Guess what that looks like in function notation? Well, I have d at 50. And what do? I plug in 50. Everywhere there's a v. I do some math. I square 50. I multiply by 0.05. That gives me 125. I do 2.2 times 50, which gives me 110. I add those two things together and end up with 235. This is a word problem. So the required distance is 235. What were we traveling in? What was our velocity? Our velocity is in miles per hour and our distance is in feet. All right, so it's feet. Okay, I know it's not even though the velocity was given to us in miles per hour, the distance is given in feet, and that is just from the problem. They tell us distance is in feet and speed is in miles per hour. Okay, so they tell us that when I plug in the speed in miles per hour, I'm going to get out distance in feet. So the math is already done for us. Unlike the problem with the vertical leap, where they didn't tell us the output, where they didn't specifically tell us the output unit. So part B, up to what speed to the nearest miles per hour could a motorist be traveling and still have adequate time to avoid hitting a deer 330 feet away? So in part A, they gave us the velocity, asked us to find the distance. Now, what are they doing? They're doing the opposite. They're telling us if I set my equation d of v equal to 330, they want us to find v. All right, so the equation is d of v is equal to 0.05 v squared plus 2.2 times v. One day, I'm going to decide to write t or write 2's with a loop or without a loop. But just today's still not that day. All right, so there's the equation, and they're telling us that the distance that I want to stop in is 330 feet. So that means d of v is 330. Not v is 330. That's the grand temptation here. Okay. d of v is 330, right? I'm looking for the v that returns 330. Okay. If I say it one more time, it'll make perfect and total sense, right? No, that's not how math works. All right, this is a quadratic. I have a square term, I have a variable to the first power term, and I have a constant. It's trinomial, so I got all three terms of the quadratic, which means in order to solve it, I'm going to get all the terms on the same side. 0 is equal to 0.05 v squared plus 2.2v minus 330. That is a quadratic. And how do I solve it? Well, leading coefficient's not 1. I could do some work here, but I think just use a quadratic equation. Just go ahead, bite the bullet. There are worse things in the world. I promise you will be fine when you get done with this. Let's again remember what are our coefficients. A here is 0.05, B is 2.2, and C is negative 330. Take those and plug them in. So that means V is equal to the opposite of B plus or minus square root of B squared, which is 2.2 squared, minus 4 times A times C, all divided by 2A. A is 0.05. Now, you've been paying attention in that most recent lecture. We talked about the discriminant and how what's under the root. If what's under the root is negative, my solutions are imaginary. What's under the root better not be negative. This is an application problem, and does that occur? Absolutely not. 2.2 squared, that's minus 4 times 0.05 times negative 330. That multiplication is going to result in a plus, so we're going to jump to the calculator here, because again, we're dealing with a application problem, not a direct math problem, so I can get some decimal answers, and everything's going to be fine. So 2.2 times 2.2 is 4.84, and then I told you this was going to be 4 times 0.05 times negative 330, which is going to give me negative 66, so that's minus negative 66, which is plus 66. All over 2 times 5 hundredths is 1/10. And finish it up. 4.84 plus 66 is 70.84. Negative 2.2 plus or minus the square root, 70.84. This is where it got away from me in class. I forgot to actually then take the square root divided by 0.1. What is the square root of that number? 70.84. Square root is 8.4, and I'm going to call it 2. Yes, I'm rounding heavily here, but again, it's an application problem, so that's okay. So I'm going with negative 2.2 plus or minus 8.42 divided by 0.1. This splits into two problems, right? That plus minus means I got two answers here. Negative 2.2 minus 8.42 more is going to give me negative 10.62 divided by 0.1. Dividing by 1/10 is just going to move the decimal one place to the right. So that's negative 106.2. These are miles per hour. And does your car go negative 106.2? Absolutely not. Application problem, meaning I can't have negative speed, right? When I drive to work, I drive 55 miles an hour. When I drive back home from work, driving the opposite direction, I don't then drive negative 55 miles per hour. So we toss that answer, and we're left with what? Now I have negative 2.2 plus 8.42. So negative 2.2 plus 8.42 is 6.22 divided by 1/10, which is 62.2 miles per hour. Now, does this answer make sense? Well, let's think about what we know from the problem. The problem told us in the last part that if I was driving 50 miles an hour, it's going to take me 235 feet to stop. If I'm traveling faster, do you think it's going to take me farther to stop? Yes. And I am traveling, this is saying to stop in 330 feet. I could be going all the way up to 62.2 miles per hour. Again, not a goal. You don't want to drive 62.2 miles per hour at night because your bright lights can only see far enough ahead of you to stop within 55 miles an hour. That's why that nighttime speed limit, nighttime max speed limit is 55. So if you're driving at night, you get the brights on, you're trying to keep an eye out, you want to be safe, especially it's starting to cool down now. Keep the speed around or below 55 at night. That way you'll be able to react and you'll be able to see something in the road so you don't have a big old bill to pay when you slam into a deer or hit an armadillo or see a possum or whatever else in the world might be on the road where you are.